Okay, let's see. Number 16. The Pixel Door. A cursor hangs over a white emptiness, then drops into East Antarctica, Princess Elizabeth Land. At first there is only glare, wind-scoured ice, and a few exposed ribs of rock. Then the image snags on something it should not. A dark-edged rectangle, long and unnervingly straight, like a doorframe pressed into the continent and left there. You drag the timeline back. 2007. It is there. 2003. Still there. Jump forward, and the shape softens, then slips under a hazy overlay, as if the ice pulled a sheet over it. Antarctic myths often start this way, not with footprints in snow, but with pixels, shadows, and a screen glowing in a dark room. A place this empty can turn distance and missing context into a door. That leaves three readings people keep returning to: a human cover-up, a lost civilization, or something older than us under miles of ice. The satellite shape looked too straight to be natural. In late 2018, an Australian hobbyist blogger did what these stories usually begin with now. He did not trek across the ice. He opened Google Earth and rolled backward through the historical imagery. He focused on a remote stretch of East Antarctica in Princess Elizabeth Land, the region between 73 degrees east and Cape Penck at 87 degrees 43 minutes east. Named in 1931 and still visited by very few people. In older imagery, mainly from 2003 to 2007, he found a cluster of dark rectilinear forms. One of them swallowed the whole story. Believers put its length at 14.5 miles and said it was buried under the ice cap. The claim narrowed fast. Was it an entrance, a shadow, or a compression artifact? Not a vague mystery somewhere in Antarctica. One dark rectangle in one image window, visible in older tiles and harder to see in later ones. That gave the story momentum online. The shape mattered, but the apparent disappearance mattered more. A strange object creates one kind of rumor. A strange object that later looks blurred out becomes secrecy. A routine update starts to look like removal. A cloud mask starts to look like censorship. Princess Elizabeth Land is exactly the kind of place that makes that jump feel believable. This is the East Antarctic ice sheet, the largest mass of ice on Earth, in a region linked to real hidden structures below the surface. Not buildings, geology, buried troughs, magnetic anomaly belts, ancient landscapes. A rift in eastern Princess Elizabeth Land, the Gaussberg Rift, has been described at roughly 500 kilometers long. Russian operations linked to Mirny Station and inland routes toward Vostok add just enough real-world activity to feed the fantasy. There are genuine things under this ice that nobody can see directly. That borrowed credibility is the trap. The buried features scientists map here do not appear as neat, dark rectangles in Google Earth. They come from radar, gravity, and magnetics. They come from long survey lines, repeated passes, and ugly data sets that look nothing like a secret bunker reveal. Start with the shape itself. Straight edges feel artificial because the brain reads geometry as intention. Satellite systems do not. They collect the world in scenes, and scenes come in rectangles. Polar mosaics make this worse. They are stitched together from limited, cloud-free, sunlit acquisitions, often taken in different years, from different angles, with different contrast conditions and different resolutions. So when a crisp line shows up in Antarctica, architecture is not the first suspect. The data product is. That matters here, because the rectangle's strongest feature is also the one least consistent with a real thing in the ice. It fits the logic of image tiling too well. The border is too clean. The effect depends too much on one viewing context. Change the mosaic, and the door changes with it. The older imagery window is part of the seduction. From roughly 2003 to 2007, the dark-edged form is easier to pick out. Later mosaics look softer, lower detail, almost washed over. For believers, that is the cover-up moment. In practice, Google Earth is not one photograph taken once and preserved forever. It is a patchwork built over time from different source scenes, with cloud masking, seasonal snow differences, compression, licensing changes, and quality updates colliding inside one interface. Antarctica is one of the hardest places on Earth to render cleanly. The surface gives almost no visual context, and usable imagery is patchy. Then scale cuts through the fantasy. If you want to decide whether the dark rectangle is an entrance, a shadow, or an artifact, 14.5 miles is the check that matters. That is not a hidden hatch. It is not even a plausible roofline. A rigid man-made rectangle that large, expressed at the surface, would not need internet detectives to spot it. It would show up across multiple satellite sources, repeat seasonal views, radar profiles, and survey flights over East Antarctica. That corroboration does not exist. What does exist is a familiar pattern: single-view imagery, low context, hard contrast between snow, rock, and shadow. A rectangular boundary behaving more like a scene edge than an object. Later imagery does not erase a structure so much as swap one visual artifact for another, less dramatic one. So the local mystery closes the moment it meets. The Czech conspiracy threads rarely survive. Scale against source. Invisible imagery, Antarctica keeps producing doors, ruins, and UFOs, because pixels can mimic intention from far enough away. In geophysical data, Princess Elizabeth Land does hide vast things beneath the ice, but they are sprawling, irregular, and measured in survey lines, not dark frames on a consumer map. The rectangle near Princess Elizabeth Land was never ground confirmed. No scientific survey reproduced it as a structure. The famous 14.5-mile figure came from the claim itself. Number 15. The Frozen Pyramid. If a mountain looks engineered from orbit, what are you actually seeing? A monument, or the geometry ice leaves behind after millions of years of work? In 2016, a cropped satellite image from Antarctica's southern Ellsworth Mountains started spreading online with the kind of certainty that Antarctica seems to invite. A white peak, 4 steep faces, sharp ridges meeting at a point. The coordinates most often attached to it were 79 degrees, 58 minutes, 39.25 seconds south, 81 degrees, 57 minutes, 32.21 seconds west. No official monument, no expedition camp, just an unnamed summit near the Heritage Range rising out of the ice. Then the screenshot broke away from the landscape around it, and the shape took over. It looked less like geology than design. The illusion has a simple advantage. Antarctica erases scale. No trees, no roads, no houses. No person standing in frame to tell your eye how large or ordinary the thing really is. A faceted peak in the Alps reads as a mountain because forests and neighboring summits sit around it. In Antarctica, the same kind of peak can read as architecture. The white emptiness strips away every comparison. So the image went where Antarctic images usually go. Lost civilization, covered entrance, ancient builders, a mountain wearing the outline of a monument. Pull the camera back a little, and the story changes. The Ellsworth Mountains are not a lone white stage set. They are a real mountain chain in West Antarctica, about 200 miles long and roughly 30 miles wide. They hold ridges, cirques, glaciers, exposed rock, and Antarctica's highest summit, Mount Vinson, rising 4,892 meters above sea level. Parts of this region entered modern geographic awareness during Lincoln Ellsworth's flights in 1935, when aircraft photography began replacing blank space on the map with actual terrain. Surveyors followed, then better imagery, then satellites. The sharp peak from the viral image did not come from nowhere. It belongs to a system. Inside that system, one word matters more than pyramid: nunatak. A nunatak is simply rock projecting above an ice sheet or glacier, not buried architecture. The reverse. Rock left exposed because the ice and snow lie lower around it, or because the mountain rises through them. You are not looking at something hidden under the ice. You are looking at what the ice did not swallow. The shape still needs an explanation. Why the faces? Why the near symmetry? Why does one summit look as if someone cut clean planes into it? Because glaciers do more than cover mountains. They carve them. Picture several glaciers working on the same high mass from different sides. One bites a bowl into the rock. Another does the same from a neighboring face. Then a third. Then a fourth. Over time, broad shoulders are pared away. Slopes steepen. Ridges narrow into knife edges. The summit left behind becomes a horn, what geologists call a pyramidal peak. Not because it is artificial, but because ice is very good at producing straight-looking results. Start with the carving. One glacier can leave a steep wall. Two can sharpen a ridge. Three or four cutting into the same mountain can leave something uncannily geometric, especially when snow fills the small irregularities and satellite light flattens depth. Freeze-thaw helps. Fractures widen, blocks fall. Faces clear themselves. From one angle, the result can look less like erosion than intention. That is what makes the viral peak convincing. It does not break the rules of Antarctic geology. It follows them so cleanly that the finished form resembles a human symbol. The same continent that hides more than 400 subglacial lakes beneath kilometers of ice also produces surface shapes dramatic enough to feel staged. The secret is real, just not the one the screenshot promised. One loose end remains. Which exact unnamed summit does the famous image show? Popular reposts usually pass around coordinates and copies of copies, not a formal Antarctic place name entry tied neatly to that specific point. The broad identification is solid, an exposed peak near the Heritage Range in the Ellsworth Mountains. The neat internet version is not. Even the object at the center of the claim reaches people, slightly blurred by reposting. That leaves a quieter, stranger scene. The pyramid is not famous because explorers found an impossible structure in Antarctica. It is famous because a normal glacial horn, cut out of its landscape, became more persuasive than the landscape itself. Then, the mountain slips back into the range. The monument disappears. A nunatak remains, a few dark faces above the ice, and wind pushing snow along the ridgelines. Number 14. The map before the ice. The map seemed to remember a continent before Europe founded. In this age, there is no map like this map in anyone's possession. That note appears on a sheet of gazelle skin parchment dated 1513 and signed by the Ottoman admiral and cartographer Piri Reis. He was not standing on Antarctic ice. He was working at the edge of an empire, compiling intelligence as Portugal and Spain pushed west across the Atlantic. On the surviving third of his world map, you can see Western Europe, the bulge of West Africa, Brazil, islands in the Caribbean, and then, along the lower edge, a coastline that seems to peel away from South America and bend east into something else. The mystery sits in that single curve. What is that lower coast supposed to be? Piri Reis left notes of his own. In the margins, he said he compiled the map from around 20 earlier charts, including Portuguese sources and one linked to Christopher Columbus. From the beginning, this was a document of transmission, not revelation, a copied world, a stitched world. In 1517, after the Ottoman conquest of Egypt, he is commonly said to have presented the map to Sultan Selim I. Then, it disappeared from ordinary history for more than 4 centuries. In 1929, workers at Topkapi Palace in Istanbul uncovered the fragment again. That rediscovery is what brought the map into modern scholarship. At first, the excitement had little to do with Antarctica. Historians cared because the map might preserve traces of lost Columbus-era cartography. A document from 1513, built partly from even older sources, offered a narrow view into the first decades of Atlantic exploration, as they were being drawn, copied, and misread in real time. Then, in the mid-20th century, the map took on a second life. In 1966, Charles Hapgood published Maps of the Ancient Sea Kings and argued that the disputed southern land was not South America at all. He said it was Queen Maud Land in Antarctica, surveyed before ice covered it. The claim landed hard for a reason. Antarctica is the perfect stage for hidden knowledge, and here was a document that seemed to have been hiding it in plain sight since 1513. A coastline from a lost age, preserved by an Ottoman compiler who did not know what he had. It sounds crushing. Antarctica was not confirmed by modern explorers until 1820, so if a map from 1513 truly showed its coast, it would not just be early, it would be impossible. But that argument stands only if the lower shoreline is Antarctica. To make it Antarctica, the map has to be forced into the role. Look at the geography as it sits on the parchment. The southern extension grows directly out of South America's coast. It is attached, not separate. The angles are odd, yes, but early 1500s Atlantic maps are full of odd angles. Coastlines were copied from pilots' charts, merged at different scales, bent to fit inherited ideas, and pushed into spaces no one had surveyed cleanly. The standard explanation does not need a vanished civilization or an ice-free survey of the polar south. It needs something Renaissance cartography produced constantly: distortion. The rival reading needs much more. The lower coast has to be rotated, then stretched, then renamed. Rivers turn into something else. Headlands turn into something else. A warped continuation of South America becomes Queen Maud Land only after the map is corrected until it matches the claim. Seen that way, the direction of the argument flips. The map is not identifying Antarctica by itself. Antarctica is being laid over the map from outside. There is another problem, quieter but stubborn. Queen Maud Land lies thousands of miles from the South American coast. On the parchment, this disputed landform leans straight out of South America's lower edge, like an overgrown tail. That is what you would expect from a speculative continuation built from incomplete reports. It is not what you would expect from a faithful memory of a separate continent. The famous curve feels uncanny because the modern eye wants a missing landmass. A 16th century cartographer may simply have wanted the coastline to continue. So, after all the comparisons are done, what is that lower coast? Most historians of cartography end up in a far less cinematic place. It is best understood as a distorted southern extension of South America, shaped by mixed source maps, copying errors, uncertain latitudes, and the geographical guesswork of 1513. It is not proof that sailors saw Antarctica before Europe officially did. It is proof that mapmakers often had to draw the edge of knowledge before they knew where that edge was. That leaves the map's significance somewhere stranger and, in a way, more valuable. Officially, it is famous as the Antarctica map. In practice, its greatest importance is probably not a hidden polar continent at all. It is a fragile echo of lost Columbus-era information, a surviving fragment of the moment when discovery was being translated into paper and the world was still being measured wrong. Number 13. The Invented South. In Paris in 1531, a royal mathematician engraved a world that looked as if it already knew too much. The oceans open in two heart-shaped halves. The Americas are there. Magellan's route is folded in. At the very bottom, where European ships had barely begun to guess, an enormous southern land is already waiting. A quick look gives you the shock at once. A continent at the end of the world, drawn almost 300 years before the first confirmed sighting of Antarctica in 1820. That is how the legend begins. The continent drawn from theory before ships could prove it. Arance Finet was not a fringe mystic or a forgotten sailor with secret charts. He was born in 1494. In the same year this map appeared, he became the first royal chair of mathematics at the Collège Royal. He built his reputation as a mathematician, astronomer, and instrument maker. When he published his Nova, Et Integra Universi Orbis Descriptio in 1531, the map carried authority. Not absolute authority, but enough to make later viewers stop and stare. Across nearly an entire lower hemisphere, Finet placed Terra Australis. He did not tuck it into a corner, he declared it. The southern land, recently discovered, but not yet fully known. That line holds the whole puzzle. Read carelessly, it sounds explosive, as if someone in the early 16th century had somehow surveyed the Antarctic coast and slipped the result into a Paris print shop. But the phrase does not require a vanished expedition. It fits a much closer event. The new reports coming back from the Strait of Magellan, the violent channel at the tip of South America, reached only a decade earlier. Sailors had seen land there. Cartographers did what cartographers often do when the evidence stopped at the horizon. They extended it. That matters for the deeper secret running through Antarctica's story. Not everything hidden under the ice was hidden by ice. Some of it was hidden on paper first. Finet's map looks modern enough to invite trust. That is part of the trap. The projection is elegant. A double cordiform world split into two hearts, one northern and one southern. It takes in Columbus. It takes in Magellan. It tries to reconcile new Atlantic discoveries with an older classical picture of how the world should be arranged. But the same sheet fuses North America to Asia. A coastline that should be broken by an ocean is joined into a single mass. This is not a secret modern survey. It is Renaissance geography doing its best with fragments. So why does the southern land feel uncanny at all? The map is not trying to record Antarctica. It is trying to complete the Earth. For many Renaissance geographers, a giant southern continent was not a wild fantasy. It was a balancing principle. Too much land in the north seemed to demand land in the south. Symmetry mattered. Completion mattered. Classical geography left room for a counterweight below the equator, and mapmakers filled that room long before ships could test it. Terra Australis was less a discovery than a requirement. You can feel that logic at work. Europe, Asia, North Africa, the newly expanding outlines of the Americas, all of it crowds the upper half of the globe. The lower half cannot stay empty, not on a page built to look whole. So the coast continues. The unknown acquires a shoreline. A rumor at the end of South America becomes the northern rim of a continent no one had actually seen. That is the colder version of the story. Not that someone knew Antarctica too early, but that educated mapmakers could produce something Antarctic-looking without Antarctica ever entering the room. Strange enough on its own. Once that shape existed on paper, later centuries could read it backward. Viewers who already knew the outline of Antarctica looked down at Finet's map and saw resemblance. A cape here, a bend there, a continental sweep across the south. But resemblance is not proof of contact. It is what happens when a speculative form is compared to a real one after the fact. The eye starts correcting. It forgives the errors it wants to forgive and enlarges the coincidences it wants to keep. Finet gave those viewers plenty to work with. His Terra Australis is huge. It curls and stretches with enough ambiguity to invite pattern matching. It feels substantial because he engraved it with confidence. Yet, confidence on a map is not the same as observation. It can also come from inherited geometry, copied assumptions, and the pressure to leave no blank edge at the end of the world. There is still an open technical question around its exact outline. How much came from earlier speculative globes, including traditions already circulating before Finet? How much was nudged by scattered voyage reports from southern waters that survive only indirectly? Historians can argue over that mix, but the argument stays inside a much narrower boundary than the myth allows. None of it requires a lost chart of an ice-free Antarctica. So the southern continent on Finet's 1531 map is real in one sense, and unreal in the one that matters most. Real as an object on paper, real as a Renaissance conviction, real as the earliest known map bearing the name Terra Australis, according to the Library of Congress. Not real as confirmed Antarctic coast. It entered cartography before it entered navigation. It was not drawn from a hidden encounter. It was drawn as a cartographic assumption. Number 12. The Nazi Survey. On December 17, 1938, Captain Alfred Richer stood with rushed orders beside a ship built to launch aircraft from open water, not to feed legends. The vessel was the MS Schwabenland, a former freighter converted into a Lufthansa catapult ship. In Hamburg Harbor, she took on 2 Dornier flying boats, fuel, cameras, survey gear, and a mission secret enough to ignite later fantasies. But secrecy alone does not explain what those aircraft were doing over Queen Maud Land. Richer was born in 1879. He was a naval officer and pilot. When this voyage began, he was not hunting ruins under the ice. He was running a practical operation at the edge of the map. Germany wanted reach in the South Atlantic and Southern Ocean. Norway was already active along that coast through whaling and exploration, and the German plan had reached the Norwegian geologist Adolf Hoel before the expedition arrived. By the time Schwabenland turned south, this was not a blank white void. It was a contested coastline, and cameras were coming. The ship reached the Antarctic coast on January 19, 1939. Ice on one side, dark water on the other. Inland stood a wall of white, broken here and there by mountains, nunataks, and exposed rock. That broken surface mattered. Aircraft could read it in a way a ship could not. Between January 20th and February 4th, whenever weather and sea ice allowed, the Dornier flying boats were fired from Schwabenland's steam catapult and sent inland on long survey tracks. One of them was named Boreas. They did not drift, they flew lines. They photographed glaciers, ridges, and rock islands pushing through the ice across a sector roughly from 12 degrees west to 20 degrees east. This is the part conspiracy stories usually smear over. German aircraft flew over Antarctica in 1939. That image is real. So is what sat behind it, a floating airbase and a camera shutter. Photogrammetry drove the mission, not occultism, not tunneling machines, not a hidden city under the ice. Schwabenland had already served in Lufthansa's transatlantic mail system. The same launch technology used for commercial seaplanes was repurposed here for polar mapping. The aircraft took overlapping aerial photographs, so landforms could later be measured and turned into charts. This is one of the clearest places in the Antarctic story where myth grew directly on top of technical reality. People saw swastikas, flight paths, secret orders, and a blank continent. At the center of the mission was a survey camera. The Germans named the mapped area New Swabia, after the ship itself. They dropped metal markers bearing national emblems. They photographed enough terrain that 558 surviving listed air photographs are still traceable in modern archive metadata. You can follow them today as records, not rumors. Image numbers, flight references, mapped positions. So the issue is no longer whether planes flew there. They did. The real point is what they were doing. Part of the answer is prestige. Part is territorial signaling. Part is whaling economics. Germany had strong reason to care about Antarctic waters because whale oil mattered industrially, and good charts mattered to anyone operating at the ice edge. That practical answer never spread as fast as the fantasy version. Practical answers come with weather windows, sea ice, and processing delays. Fantasy gives you caverns. The expedition also left behind the kind of gaps fantasy likes. By April 1939, Schwabenland was back in Hamburg. Within months, Europe was sliding into war. Some of the mapping work was interrupted. Some photographic material was damaged, dispersed, or lost. Sources differ on how much disappeared and how much survives unprocessed in archives. What remained was a volatile mix. A real secretive mission, real aircraft, real markers, real photographs, and an incomplete paper trail. Later stories moved straight into that space. Picture the scene. You were in a flying boat over Antarctica in early 1939. Below you, a continent almost no one on Earth has seen from this angle. The ice breaks open into dark rock. Mountain chains appear where the map had said almost nothing. You bank, photograph, turn, and head back toward a ship waiting in freezing water. It feels like the opening of something vast. Feeling is not the record. The record is colder than the legend. This expedition built no underground base there. It left no overwintering party behind. No station rose out of Queen Maud Land after the aircraft passed overhead. The documented operation was a short Antarctic survey voyage led by Alfred Richer, carried out from December 17, 1938 to April 1939, using Schwabenland and 2 Dornier flying boats to photograph and chart terrain later labeled New Swabia. In the surviving images and documents, it was aerial reconnaissance for mapping, whaling, science, and acclaim. Then the ship turned north. Number 11. The Armada on the Ice. The operation was too large for people to accept as ordinary. On December 30th, 1946, a U.S. Navy PBM-5 Mariner called George I lifted off from the seaplane tender USS Pine Island and flew into Antarctic whiteout. Its assignment sounded simple: photograph coastline, test navigation, turn blank ice into usable maps. The force behind that flight was not small. Task Force 68 went south with 13 ships, 23 aircraft, and about 4,700 men under Rear Admiral Richard H. Cruzen, with Rear Admiral Richard E. Byrd as the officer in charge and the public face everyone recognized. A formation that size is exactly what kept the rumors alive. Why send what looked like a naval armada to the bottom of the world, barely a year after World War II ended? The key date comes before the crash, August 26, 1946. That was when Operation Highjump was initiated by the Chief of Naval Operations. This was not some distant age of exploration. It was the immediate post-war world, when the United States had ships, aircraft, trained crews, and fresh memory of what happened when strategic gaps were ignored. Antarctica was a continent-sized blank on military maps. The Navy treated it like one. The numbers tell the story clearly. 13 ships was not a token escort. 23 aircraft was not a decorative air wing. 4,700 men was not a skeleton expedition. This was a force meant to do several jobs at once: operate in extreme cold, test equipment, practice aerial photography, study ice conditions, establish a base, and learn whether men and machines could function at the far edge of navigation. Little America 4 rose on the Ross Ice Shelf as the expedition's base. Aircraft pushed outward over terrain that resisted measurement. Ships worked through pack ice that could close like a door. Later mythology flattened all of that into a fantasy battle. People hear post-war Navy, Byrd, Antarctica, and a task force that size, and they assume the public explanation must be too small for the machinery involved. The documented mission was large because the continent itself was large, hostile, and unknown. It was cold enough to disable engines, empty enough to defeat navigation, and strategically blank enough to worry planners. If Antarctica was the perfect place to hide something, then in 1946, one of the things hidden there was not a secret base. It was ignorance on a map. George 1 shows what that looked like in practice. You are low over an empty world. No roads, no landmarks, no depth cues. Light, ice, and weather blur into one surface. The mariner was flying reconnaissance in bad visibility, looking for coastline and photographic coverage. Antarctica did not need enemy fire to kill you. Distance and white were enough. George 1 struck a ridge and burned. 3 men died. 6 survived on the ice. That crash breaks both easy versions of the story. This was not harmless pageantry. Men were flying and landing in conditions that could erase the horizon and the ground at the same time. It was also not the pulp version, not a secret war under the ice against hidden enemies with impossible weapons. The threat was simpler than that and more dependable. Poor visibility, featureless terrain, and the basic fact that Antarctica could make advanced machines suddenly primitive. So why did the force leave so soon? That part of the timeline fed the legend. Highjump began under official authority in late August 1946. The active Antarctic season was compressed, and by late February 1947, the expedition was ending earlier than many people later thought a fleet of that size should. For conspiracy culture, the mismatch was irresistible. Huge force in, short stay out. So they filled the gap with a story about discovery, combat, and retreat. The records point somewhere less cinematic and more brutal. Weather narrowed the operating window. Sea ice and logistics set hard limits. Antarctic flying was dangerous. Surface operations were slow. Mapping white space sounds abstract until you picture what it meant. Men trying to photograph, navigate, and return across one of the least forgiving environments on Earth with 1940s equipment. A fleet can look immense at anchor. Over Antarctica, cloud, ice, and distance can still beat it. Byrd's presence amplified everything. He was already one of the most famous polar names alive, so the expedition arrived with myth built into it. Add wartime hardware, a remote continent, a short season, and a crash like George I, and later storytellers had all they needed. Training became combat. Reconnaissance became pursuit. Logistical limits became evidence of suppression. The surviving paper trail keeps returning to practical goals. Test men, test ships, test aircraft, establish a base, improve techniques, collect photographs, extend maps. On January 11, 1947, after 12 days on the ice, the 6 survivors of George 1 were finally rescued. That is the scale of the real fight in Highjump. A downed crew waiting on Antarctic ice, while the largest American expedition ever sent south tried to learn, fast, how not to die there. The official purpose was later summarized in words far plainer than the myth: training personnel and testing equipment in frigid zones. Number 10. Byrd's missing door. So what did Byrd actually find down there, if the stories insist it was more than ice? Picture the fire burning low, the wind cutting hard, and a famous name doing half the work on its own. Richard E. Byrd had the kind of biography legends latch onto: medals, headlines, aircraft over blank white maps, and just enough uncertainty to leave a door cracked open. If Antarctica is the perfect place to hide something, conspiracy culture picked Byrd to walk into it. His name became a passport to a world below. On May 9, 1926, Byrd and pilot Floyd Bennett lifted off from Spitsbergen in the Fokker tri-motor Josephine Ford. They came back claiming they had reached the North Pole. It was the kind of feat that turned a man into national property overnight. Ice below, open ocean leads, a point on Earth no road could touch. Newspapers treated it as a clean triumph. But the crack in Byrd's legend did not start in Antarctica. It started in the Arctic, in the math. In 1996, researchers in the Ohio State University archives found Byrd's 1926 flight diary. Not the later secret diary passed around in hollow earth circles. The real one. Paper. Navigation. Fuel concerns. Erased sextant notes. Those erased notes mattered. They suggested Byrd may have turned back about 150 to 165 miles short of the pole. Not a small error. Not a rounding problem. A gap big enough to move a hero off the exact point that made him famous. 3 days after Byrd's claimed flight, on May 12, 1926, Roald Amundsen, Lincoln Ellsworth, and Umberto Nobile crossed the North Pole in the airship Norge. If Byrd did fall short, then Norge becomes the first confirmed aerial crossing. So the man later tied to hidden Antarctic entrances already carried something myth loves more than certainty: a disputed polar victory. That is where the campfire version starts to glow. A real explorer, a real diary problem, a real blank space at the top of the world. Then the story jumps the rails. By November 29, 1929, Byrd had done something nobody disputes in the same way. He flew over the South Pole with Bernd Balchen and crew. That flight locked in his Antarctic fame. The southern continent gave him what the North no longer could, a grand success that held. Then came the war. After it came Operation Highjump in 1946 and 1947, the expedition already inflated into battle stories before the ice season ended early. The ingredients were all there now: a famous polar commander, a remote continent, military hardware, and an audience ready to believe the official record had left things out. The Hollow Earth tale did not need to invent Byrd. It only needed to borrow him. In that version, a supposed secret diary describes Byrd flying not over ice, but through an opening near the pole into a green interior world. Mountains where there should be flat glare, animals where there should be nothing, advanced beings, warmth, a hidden civilization under the earth. It is a perfect Antarctic fantasy. The continent's biggest visual fact, all that blank white emptiness, becomes camouflage for a door. Around a fire, with darkness pressing just beyond the circle, it sounds almost efficient. A secret base hidden there, a lost world using the poles as entrances. The admiral who kept flying where maps faded becoming the one who saw it. The story flatters geography. It flatters the listener, too. You are not being asked to believe nonsense. You are being waved past the official curtain. The authenticated record is dull in the way truth often is. The real Byrd archive gives navigation, weather, timing, mechanical strain, ambition. The 1926 controversy is about whether he reached the North Pole, not whether he descended into an inner Earth. The Antarctic fame is real. But the text most often quoted by Hollow Earth believers is not the Ohio State Diary that reopened the 1926 dispute. It is a later, alleged, secret diary that circulated decades afterward in UFO and Hollow Earth communities, attached loosely to Byrd's name and to a supposed 1947 polar flight. That is a different thing entirely. You can feel the break if you follow the paper instead of the legend. In Byrd's verified materials, the details get smaller as they get stronger. Flight times, sextant readings, oil leaks, distances, crew names. In the Hollow Earth text, the reverse happens. The scale swells just as the documentation disappears. Suddenly there are hidden realms and extraordinary encounters, but not the kind of expedition record that made Byrd famous in the first place. So when people say Byrd found more than ice, they are building that claim on the wrong diary, the wrong chain of custody, and often the wrong pole. The real scandal tied to Byrd's name is an Arctic navigation controversy from May 1926. The inner world story came later. It fastened itself to a genuine wound in the legend and used it as an entrance. The missing door appears there, not on the ice, not in the sky, in the records. The story stays attached to Byrd right up to the point where authenticated expedition documents end and the alleged secret diary begins. Then the paper trail breaks. Decades later, somewhere between Byrd's archived notes in Ohio and a typewritten world under the pole, the door opens and the record does not follow. Number 9. The Breathing Mountain. In December 1972, high on Ross Island, New Zealand, geochemist Werner Giggenbach stepped into a white tower near camp on Mount Erebus and found that Antarctica was breathing. Outside, the mountain looked simple at first glance. Wind, ash-dark rock, snow hammered flat by cold. Above him stood the southernmost active volcano on Earth, a summit now usually listed at about 3,794 meters. But the opening in front of him leaked steam-rich gas into air so cold that the mountain's breath froze into walls. What looked like an ice chimney from a distance was hollow, so he climbed inside. The tower did not end in a small pocket. It opened into a hidden system beneath the summit plateau, roughly 400 meters long. No river had carved it. No summer meltwater had bored through it. Heat rose from below. Fumarolic gases melted snow and ice from underneath. The escaping vapor froze again at the surface into pale vertical stacks. In one of the coldest places on Earth, mouths in the ice were giving off steam. Antarctica has volcanoes. Erebus is not strange because fire sits under ice. It is strange because the ice has openings that seem to breathe. Stand there for a moment and the geometry turns unsettling. The tower is not the cave. It is the exhaust. The visible part is the chimney. The real structure lies under your boots. Warm gas rises, the outer skin freezes, and the mountain builds itself a temporary throat. Some of these fumarolic areas carry names that sound half like field notes and half like warnings. Ice Tower Ridge, Tramway Ridge, Hut Cave, Warren Cave, Cathedral Mammoth, Sauna. Partway up, the name makes sense without explanation. An entrance where the continent exhales through ice. Deeper in, the caves stopped being scenery. They were not just dramatic voids for photographs. Decades after Giggenbach's team described that first hidden passage, scientists returned with different questions. Warren Cave, Harry's Dream, Hubert's Nightmare. In those cave systems, researchers sampled sediments, mapped temperatures, tracked carbon dioxide, and looked for life in a place with almost no sunlight, little organic food, volcanic gas, and cold that should have made survival simple by ending it. It did not. Warren Cave, one of the best studied, is completely dark. The Mount Erebus Volcano Observatory used it to study CO2 emissions and temperature fluctuations, because the cave acts like a sealed chamber over an active heat source. Later teams looked for something even harder to see than the gas. Microbes, fungi, cells tucked into sediment and ice where the surface world barely reaches. Not on a tropical volcanic island, not in a warm spring. Here, under Antarctic ice, in the breath of a volcano. In 2011, researchers pushed the forensics further with fiber optic distributed temperature sensing inside an Erebus fumarolic ice cave. Meter by meter, the cable turned the cave into a thermal map. It did not show one evenly warm chamber. It showed point sources, localized geothermal hotspots. The cave was not vaguely heated. It was being fed in specific places, like a body with pulses under the skin. So the question across Antarctica shifts. Not whether Erebus makes strange ice. It does. The harder question is what survives when a place looks sealed from the outside. In these caves, isolation is never complete. Gas moves, heat moves, moisture condenses. Chemistry keeps working in the dark. The ice on this mountain is not simply preserving a secret. It is shaping one. There is a practical edge to this mystery. Astrobiologists treat these caves as analog worlds because they combine darkness, mineral surfaces, geothermal energy, intermittent liquid water or condensate, and shelter from the brutal conditions outside. If life can hold on here, in a volcanic cavity under Antarctic ice, then frozen worlds elsewhere in the solar system look slightly less dead. Erebus matters for another reason too. It is real, filmable, reachable, and stubbornly physical. Not a rumor from one blurry satellite pass. Not a shape argued over from orbit. You can walk up to the tower. You can watch vapor freeze on its lip. You can enter the cave, measure the carbon dioxide, scrape the sediment, culture what grows, and still leave with the sense that the mountain has kept the central mechanism just out of sight. At the surface, the openings still look impossible. Steam where there should only be ice. Warm chambers where there should only be wind-packed snow. White towers that seem to grow from nothing. The first impression is that Antarctica has holes in its cold. It does. The cold did not fail. Late on Erebus, when the light goes flat and the vapor thins into the air, the towers stop looking like buildings and start looking like breath made visible. The caves exist because the mountain beneath them is still alive, feeding heat and gas upward through the frozen shell. What looked like openings in the ice were vents from the fire below. The secret was not buried under Antarctica. It was rising through it. Number 8. The Red Leak. In 1911, Australian geologist Thomas Griffith Taylor was crossing the ice-free floor of Taylor Valley when he saw red liquid pouring from the front of a glacier onto the frozen surface of West Lake Bonny. Not a faint tint, a wound-colored spill across white ice in one of the driest places on Earth. The McMurdo Dry Valleys cover roughly 4,000 to 4,800 square kilometers of East Antarctica. Some parts get less than 6 millimeters of water-equivalent precipitation in a year. Mean air temperatures sit around -20 degrees Celsius. Almost nothing here is supposed to flow. Yet this did, and it came out red. The first explanation sounded easy. Red algae, a surface bloom, something biological staining the ice from above. It matched the color, and it matched a familiar habit. Pick the least disturbing answer first. Then the chemistry kept breaking that story apart. The stain did not act like a film spreading across the glacier face. It came from inside the ice itself. It appeared in irregular pulses, as if pressure behind the snout was forcing liquid through hidden channels. This was not color resting on Antarctica. It was liquid escaping from within the glacier. Antarctica invites the same mistake again and again. See something impossible, assume it is a surface effect, move on. Blood Falls was not that. The red streak was the smallest part of the problem. Something beneath the ice was staying liquid in a polar desert and moving through a glacier that should have been frozen solid. Stand in Taylor Valley for a moment. The wind is dry enough to chap skin raw. The ground looks more Martian than Antarctic. Bare rock, gravel, hard light, almost no snow. Ahead is Taylor Glacier, dropping into the valley and ending above West Lake Bonny. Then a dark red trickle appears from the blue-white front and spreads over the ice like fresh rust thinned with water. It looks alive. The evidence points the other way. In the 2000s and 2010s, microbiologist Jill McCuckey and her colleagues stopped treating blood falls like a spectacle and started treating it like an exposed pipe. They did not have to drill through kilometers of ice. The glacier was bringing the sample out for them. The outflow opened a direct path into a sealed environment hidden within or beneath Taylor Glacier, cut off from sunlight and ordinary contact with the atmosphere for a very long time. Some studies linked that trapped water to ancient seawater or to a Paleolake system left behind when ice advanced through the valley. One leading scenario reaches back to a marine incursion in the Pliocene, around 5 million years ago. The picture shifted. This was not algae on the surface. It was brine, locked in cold darkness. Water salty enough to stay liquid at about -6 degrees Celsius, even at atmospheric pressure. Water carrying dissolved chemicals from a world without light. Water moving under one of the coldest deserts on Earth. And it was not sterile. Samples showed microbial life surviving in that buried brine, and using chemical energy instead of sunlight. No photosynthesis. No warm surface pond. a hidden ecosystem running on rock-water chemistry in the dark. Blood Falls stopped being just an oddity or a horror movie image. It became a natural borehole into an Antarctic habitat that should have been almost unreachable. One problem remained. If the brine was trapped, how was it moving? Why did it emerge in pulses instead of as a steady seep? Later, geophysical surveys expanded the map beneath Taylor Valley. They found low resistivity brines below the surface and tied Blood Falls to a broader, hidden groundwater system. The red trickle at the glacier front was not one isolated pocket draining away. It was part of connected plumbing under the valley floor, a network of buried saline water threading through frozen ground and ice. The myth falls apart at every point. The red was not a curse, not a bloom, not a trick of light. It was chemistry revealed late. While the fluid stayed sealed away from oxygen, it did not look bloody at all. Only when it reached open air at the glacier front did the dissolved iron react, oxidize, and turn the deep rust-red color Thomas Griffith Taylor saw in 1911. The blood appeared at the surface. The source had been hidden much longer, so the first answer turned out stranger than the legend. Blood Falls is red because iron-rich brine from an ancient sealed subglacial system reaches the surface and rusts in the air. The flow once blamed on surface algae is coming from water that may have been isolated since a marine incursion roughly 5 million years ago. Number 7. The lake that answered. At 5 a.m. on January 28, 2013, a drill team on the Whillans ice stream watched instruments twitch in the dark and realized they had just touched water no human had ever sampled directly. Above them sat about 800 meters of West Antarctic ice. Below them was a lake they had spent years trying not to ruin. The buried lake proved the darkness was not empty. 2 weeks earlier, on January 14th, the Wizard field team had reached the site after leaving McMurdo in December. Wizard stood for Whillans Ice Stream Subglacial Access Research Drilling. In practice, that meant hauling a clean hot water drilling system onto a moving body of ice and opening a narrow path into a place scientists considered scientifically priceless and dangerously easy to contaminate. John Priscu of Montana State University was one of the lead scientists. The risk was obvious from the start. If they punched through with dirty equipment, if a single part of the system carried the wrong microbes downward, the result would be useless. Not because the lake had failed, but because the humans had arrived first. That fear sat over Lake Whillans the whole time. By the Wizard years, researchers knew of more than 400 subglacial lakes in Antarctica. Lake Vostok had already turned contamination into a global argument. Whillans mattered for another reason. It was not a sealed pocket sitting under the ice. It was part of the plumbing beneath an active ice stream, a dark water system helping control how ice slides toward the Ross ice shelf. If life existed down there, it was not life in a cinematic lost world. It was life inside the machinery. When the borehole finally connected, the team did not hit a giant underground cavern. They hit something stranger. At the sampled point, Lake Whillans was only about 2 meters deep, not a black abyss, a cold, pressurized, sediment-rich layer of water spread across soft ground beneath the ice. Officially, it was a lake, and that was true. But the word lake invites the wrong picture. No stone walls, no empty blue chamber. On the instruments and in the samples, it looked more like a buried wetland in permanent night. That changed the texture of the discovery. The ice above was not resting on solid stillness. It was sliding over water, mud, and living chemistry. Between January 28th and February 1st, the team pulled up water and sediment through the clean borehole and started testing what they had reached. The water was cold, obviously. It was also oxygenated. That mattered. A completely stagnant, suffocated system would have told one story. An oxygenated one told another. Lake Whillans was connected enough to stay chemically active, but isolated enough to remain hidden under 2,600 feet of ice. Then the biology came in. Researchers found a microbial ecosystem living without sunlight. Bacteria and archaea, with no conclusive eukaryotes. No plants, no fish, no dramatic blind predators waiting for a documentary narrator to lower his voice. Just microbes in dark water over soft sediment, surviving on chemical energy from rock-water reactions and nutrients moving through the subglacial system. The finding sounds modest until you sit with it. This was not surface contamination dressed up as discovery. It was a functioning ecosystem in a place where photosynthesis is impossible. Lake Whillans also answered a question Blood Falls had left open. Hidden Antarctic water can move. Chemistry can persist in isolation. At Whillans, life did the same. Yes, not in theory, not in a model. In samples lifted before dawn from a real lake under real ice, after years of trying to make sure the first thing in that water was not us. The scene barely matched the myth. Antarctica's buried secrets are so often imagined as giant chambers, fossil cities, military vaults, whole worlds sealed under white emptiness. Lake Whillans was none of that. It was shallow, murky, sediment-heavy, mechanically important, biologically alive. The discovery did not reveal a lost civilization or some impossible beast older than us. It revealed something official reports can describe in dry language and still undersell. Beneath the West Antarctic ice sheet was a dark, oxygenated microbial habitat tied directly to the movement of the ice above it. At the start, the fear was simple. Drill into a pristine lake and you destroy the evidence. The clean hole held. The samples came back alive. The hidden lake, once just a blue patch on radar maps, was not an empty cavity under Antarctica. It was 2 meters of water over soft sediment, containing bacteria and archaea under 800 meters of ice. Number 6. The Locked Ocean. 4,000 meters, more than 500 meters of water. One station, one drill, and one problem that sounds backward the moment you say it out loud. What if reaching the lake is the mistake? In central East Antarctica, beneath Russia's Vostok station, scientists were not hunting open water when the story began. In 1959, and again in 1964, Soviet geographer Andrei Kapitsa sent seismic signals down through the ice and got something strange back. The echoes did not behave like ordinary buried rock. They came from a surface too smooth, too level, too broad. Antarctica hides scale well, so for decades the signal remained a suspicion instead of a discovery. Then the measurements sharpened. British radio echo surveys led by Gordon Robin and colleagues traced a hidden reflector below the station. Satellite altimetry in the early 1990s, including work by Jeff Ridley's group, found an ice surface above it that was unnaturally flat, as if the sheet were floating on something softer than stone. Ice does not flatten like that by accident over such a large area. It bends to what is underneath. What lay under Vostok was becoming harder to dismiss. In 1996, Andrei Kapitsa, Jeff Ridley, Gordon Robin, Martin Siegert, and Igor Zodikov published the case in Nature. Beneath nearly 4 kilometers of East Antarctic ice lay Lake Vostok, one of the largest known subglacial lakes on Earth. Not a pocket, not a wet seam, a lake. A body of liquid water, sealed from the surface for at least hundreds of thousands of years, and possibly much longer. Parts of it were estimated to be more than 500 meters deep. That changed the argument. A lake that large beneath that much ice was no longer just another buried feature. It was an isolated world under crushing pressure, in complete darkness, with a lid so thick that no wind, no snowfall, no bird, no human boot had ever touched the water directly. Antarctica's surface was not the floor, it was the ceiling. The risk now was not to the drill team, it was to the evidence. By the late 1990s, biology entered the story before the lake water did. In 1999, a science paper reported microorganisms in accretion ice above Lake Vostok. This was ice formed when lake water froze onto the underside of the moving ice sheet and was carried upward into the core. Scientists were not yet sampling the lake itself. They were reading its frozen edge millimeter by millimeter, trying to tell whether life could survive in a black, pressurized reservoir under 4,000 meters of ice. If those microbes truly came from the lake, the implications were enormous. An ecosystem could exist in permanent darkness, cut off from the atmosphere, with no obvious connection to the surface biosphere. If they came from drilling fluid, equipment, or ordinary contamination, The signal was already compromised before the main question had even been asked. The deeper the drill went, the less this resembled a simple breakthrough. It became a custody fight over purity. This was the locked ocean, a lake sealed so deep that touching it could damage the very thing scientists had come to study. For decades, the Russian team drilled downward through the ice above Vostok. The method carried a cost. Boreholes at those depths do not stay open on their own. They need fluids to balance pressure and keep the shaft from closing. Kerosene-based drilling fluid and other chemicals kept the borehole workable. They also turned the final meters into a scientific argument heard far beyond Antarctica. If the first human breach delivered modern contaminants into a lake sealed for ages, then discovery would overwrite the thing being discovered. In February 2012, the drill finally reached the lake. From a distance, it looked like triumph. After decades of ice core work, years of delay, and every mechanical and political obstacle Antarctic logistics can produce, the team had touched one of the most inaccessible bodies of water on Earth. Up close, the contact was not clean in the simple way people imagine. The borehole fluid sat above the interface. Pressure changes mattered. Refreezing mattered. Every sample carried a second identity, what it was, and what might have been introduced when humans arrived. That is the part that feels almost cruel. You spend half a century trying to enter a place because it may preserve a record of life, chemistry, and isolation, unlike anything on the surface. Then the moment you enter, you add a new layer to that record: yourself. Lake Vostok became more than a hidden lake under East Antarctica. It became a test of whether the deepest secret under the ice could survive being found at all. Under 4 kilometers of frozen weight, the water sat in total darkness. The first argument was no longer about what lived inside. It was about whether our fingerprints got there first. Number 5. The Buried Alps. The mountain range no human eye has ever seen. How do you discover mountains without seeing a single ridge? In 1958, during the International Geophysical Year, the third Soviet Antarctic expedition crossed the blank center of East Antarctica with gravity instruments and a problem. Near what is now called Dome A, the surface gave them nothing. No skyline, no outcrop, no broken rock. Just a high, smooth ice dome stretching into weather and distance. But the instruments did not behave as if the bed below were flat. The gravity signal dipped and shifted in a pattern that made no sense for a buried plane. Under kilometers of ice, the team had found mass where no mountain should have been. The first shock was the discovery itself. The second was the scale. This was not a lonely peak or a buried ridge. It was a mountain system about 600 kilometers long, with summits rising more than 3,000 meters beneath the ice, later named for Soviet geophysicist Grigory Gamburtsev. A hidden alpine landscape in the middle of East Antarctica, inside a continent supposed to be ancient, cold, and tectonically quiet. Mountains like this are not supposed to be there. The usual recipe for a big mountain range is familiar: plate boundaries, collisions, fresh uplift, exposed rock, faults you can map with your boots on the ground. The Gamburtsev Mountains sit near the center of the East Antarctic ice sheet, far from the kind of active edge where a dramatic skyline is expected to form. They are buried under ice that can be less than 400 meters thick over some peaks. On the northern flank, where the range meets the Lambert Rift, that cover thickens to more than 4.5 kilometers. The more scientists understood the setting, the less normal it looked. You can feel the contradiction from inside the landscape. You stand above one of the largest mountain ranges in Antarctica, and the horizon is smooth. You are over sharp peaks and deep valleys, but all you see is white curvature and wind-blown snow. The continent looks blank because the relief is entombed, not destroyed, hidden. For decades, that left the Gamburtsevs in a nearly absurd category of discovery, a major mountain chain that existed on paper before it existed in view. Scientists knew it was there, but they had no exposed rock to sample and no direct way to trace how it formed. So the explanations multiplied. Maybe ancient crust had thickened long ago. Maybe later rifting had reawakened and lifted the old roots. Maybe the present height was not youthful volcanism at all, but a much older structure revived from below. The buried Alps looked less like a solved finding and more like a geological crime scene with the body under the floorboards. The hidden range mattered for more than its own existence. It may answer part of the larger question running under everything in Antarctica. What is the deepest secret there? Not a bunker, not a pyramid, a mechanism. High ground at the center of a cold continent changes how ice begins. Models and topography suggest these mountains may have been the seedbed where the East Antarctic ice sheet first grew. Early snow and ice accumulated on elevated terrain, then expanded outward into something continental in scale. That flips the picture. Most people imagine ice as the force that erases mountains. Grind long enough and sharp relief softens. Valleys widen. Peaks lose their edges. But radar later showed that the Gamburtsevs still preserve steep valleys and jagged topography, an old alpine landscape held in cold storage. In some places, the ice may have protected what moving glaciers usually destroy. It froze the terrain into preservation instead of sanding it flat. A mountain range hidden by ice may also have helped create the ice that hid it. Half a century after the Soviet traverse, an international project went after the mountains from the air. In the 2008-09 Antarctic season, AGAP, with teams from Australia, China, Germany, Japan, the United Kingdom, the United States, and others, surveyed the range using instruments the ice could not fool. They could not strip away the East Antarctic ice sheet, so they used radar to sound through the ice, gravity to measure buried mass, and magnetic surveys to trace the deeper architecture of the crust. The invisible range stopped being an inference and became a mapped landscape. Radar profiles revealed sharp peaks, deep valleys, and rugged alpine terrain entombed beneath the ice. Gravity and magnetic data pointed to something even more important below that terrain, a previously unknown rift system linked to the uplift of the range. Not a young volcanic chain punching up through Antarctica yesterday, but an ancient mountain core, modified and revived by deep crustal processes over immense time. How do you discover mountains without seeing them? In East Antarctica, you measure what the ice cannot hide. In 1958, the Soviets found the anomaly with gravity. In 2008 and 2009, AGAP mapped the range with airborne radar, magnetic, and gravity surveys through up to 4.5 kilometers of ice. Number 4. The buried scar. The possibility exists that a giant meteor impact crater may lie hidden beneath the East Antarctic ice sheet. Ralph von Frese and his colleagues put that line into print after reading Antarctica from orbit instead of from the ground. No drilling rig, no rock hammer, just gravity, altitude, and a patch of East Antarctica near 70 degrees south, 120 degrees east, a location so remote that direct field access is punishingly difficult, and so ice-covered that the bedrock signal has to be inferred before anyone can even choose where to drill. In 2006, those maps began to show a shape under Wilkes Land that did not fit ordinary geology. Beneath the ice sat a broad subglacial depression roughly 500 kilometers across. But over that buried low, Grace detected the opposite of what intuition expects: a strong, positive free air gravity anomaly, a mass excess, a mascon, a hidden basin with a gravity high on top of it, a buried scar that might belong to an extinction-scale impact. From there, the story splits. One version runs straight to the headline: a supercrater under the ice, larger than Chicxulub, proof of a cataclysm big enough to reset life on Earth. Wilkes Land gave that version fuel, because the proposed structure was described as more than twice the size of Chicxulub. That is an extreme claim. Chicxulub, the impact tied to the end of the dinosaurs, already sets the scale for planetary violence. Put something even larger under Antarctica, and it does more than enlarge the blast radius. It threatens to reorder several arguments at once: what drove the end Permian extinction, how East Antarctica recorded deep-time catastrophe, and how many basin-scale scars may still be hidden under polar ice with no obvious surface trace. The actual clue was stranger than the myth, and more interesting. This was not just a circular hole under the ice. It was a gravity high over a buried depression, with flanking negative ring anomalies around it. Von Frese's team argued that the pattern looked less like a simple basin and more like the mascons seen in lunar and Martian impact structures. In those places, a gigantic collision excavates the crust and later leaves behind dense, uplifted material below the basin floor. Later modeling even invoked a mantle plug, about 425 kilometers wide and 5 kilometers thick, to explain how a depression could still produce such a strong positive signal. This is not a generic mystery. It is a forensic puzzle built from numbers that change the argument. The coordinates matter because the site sits deep in one of the least accessible interiors on Earth. The 500-kilometer width matters because it places the feature in the range where an impact would be globally consequential, not merely local. And the older 158.3 milligal anomaly mattered because it was strong enough to keep the impact interpretation alive long before Grace refined the picture, even if that earlier signal pointed in a different direction. That gave the idea weight. If this really was an impact basin, it was not only large, it was ancient, buried, and potentially connected to one of the worst biological disasters in Earth history. The Permian-Triassic boundary has been dated in one UPB zircon study to 251.4 plus or minus 0.3 million years ago, the interval of the end Permian mass extinction, when life on Earth was devastated on a scale that makes later extinctions look smaller than they should. A crater in Wilkes Land, more than twice the size of Chicxulub, offered a brutal temptation. Maybe Antarctica was hiding the blow that helped do it. And if that were confirmed, the consequence would not be a tidy addition to the record. It would force a reassessment of extinction mechanisms, usually centered on volcanism, climate collapse, and ocean chemistry. An Antarctic impact of that scale would have to be fitted into the timing, the kill mechanisms, and the debris record. It would also raise a harder geological question. If one extinction-scale basin can vanish beneath East Antarctic ice and sediment, how many other major impact structures have escaped recognition simply because the right continent froze over them? Then, the evidence narrows. The Wilkes Land anomaly did not appear from nowhere in 2006. Decades earlier, researchers had already argued over unusual gravity signatures in the region. One 1976 interpretation cited a 158.3 milligal negative free air gravity anomaly as possible impact evidence, a large enough departure from expectation to suggest something structurally unusual beneath the ice. In 1979, a rebuttal using airborne radio echo sounding came back with a colder answer. No evidence in the radar for the crater geometry that interpretation required. So the modern claim was never a clean discovery. It was a return to an old fight, armed with better tools and a more complicated signal. Earlier arguments leaned on one kind of anomaly. The later case hinged on something more counterintuitive, the mascon itself. That made the Wilkes Land feature harder to dismiss. It also made it harder to prove. Gravity can suggest buried structure, but it cannot by itself produce the diagnostic evidence that impact geology lives on. Shocked minerals, melt rock, breccia, ejecta, a datable crater floor. Drilling sounds like the obvious solution until Antarctica turns it into a different problem. You have to choose a target through kilometers of ice using indirect data, transport and maintain deep drilling systems in extreme isolation, avoid contaminating subglacial environments, and hit the right patch of bedrock in a structure hundreds of kilometers wide whose crucial diagnostic zones may be deeply altered, offset, or buried under later deposits. A failed hole would not just be expensive, it could leave the central question open while consuming the kind of logistics budget that polar science rarely spends twice on the same gamble. So Wilkes Land stays balanced on a sharper edge than viral crater maps admit. The gravity pattern remains provocative, the diagnostic impact evidence remains missing, and the one material that could change everything is specific: bedrock carrying shock metamorphic signatures, or preserved impact melt that can be chemically tied to a true crater event and dated against the end Permian timeline. Until someone reaches that layer, the threat is not that the story ends unresolved. It is that proving it may require drilling into one of the most inaccessible places on Earth. And if the core comes back positive, the real instability begins afterward, when paleontology, impact history, and Antarctic geology all have to be rewritten at once. Number 3. The Martian Stone. On August 7, 1996, President Bill Clinton stepped onto the White House South Lawn and spoke about a rock that had spent nearly 12 years in a freezer. It weighed 1.9 kilograms. It was roughly the size of a potato. NASA scientists were now suggesting it might contain traces of life from Mars. A sentence like that can shift an entire field. Not just Antarctic geology, not just Mars science. A stone lying on Antarctic ice was suddenly being discussed as evidence in the case for life beyond Earth. The story starts with a man who did not know he was picking up history. On December 27, 1984, a member of the U.S. Antarctic Search for Meteorites team was working the blue ice fields of Allen Hills near the Transantarctic Mountains. He spotted a dark rock against the ice. In Antarctica, meteorites are easier to find because the continent does two jobs at once. It preserves them. It concentrates them. Snow buries space rocks inland. Glaciers carry them for thousands of years. Mountains block or slow the ice. Then, katabatic winds and sublimation strip the surface away until the stones are left behind, black on blue, waiting to be seen. So the find did not look miraculous. It looked routine. The specimen was catalogued with the calm logic of field science. ALH 84001, Allen Hills, 1984 season. Specimen 001. A label like that can hide almost anything. For years, that was all it was. One more Antarctic meteorite in storage. One more traveler delivered by a conveyor belt of old ice. Some of it exposed for up to hundreds of thousands of years across the Allen Hills fields. More than 45,000 meteorites have now been recovered from Antarctic ice, and most of them disappear into obscurity. Then, in 1993, NASA scientist David Mittelfelt took a closer look and recognized that ALH 84001 was not ordinary at all. It was Martian. That changed everything about the rock before anyone said a word about life. This was not debris from the asteroid belt. It was a fragment blasted off Mars by an impact, launched into space, then dropped onto Earth and preserved on the coldest continent on the planet. It was also old, about 4.1 billion years old, one of the oldest Martian meteorites ever identified, an ancient piece of a world that may once have had liquid water when the solar system was young. At that point, the object stopped being just another Antarctic secret. It became a stone from Mars that had waited in Antarctic ice. After its Martian origin was recognized, the rock moved from a collection drawer to the center of a planetary argument. David McKay and his NASA-led team began examining tiny features inside it: carbonate globules, magnetite crystals, organic compounds, and structures so small they were described as worm-like. None of those clues proved anything on its own. Each one looked suggestive. Together, they looked like a pattern. Then, on August 16, 1996, in the journal Science, McKay and his colleagues published one of the most explosive papers in modern planetary research: Possible Relic Biogenic Activity in Martian Meteorite ALH 84001. You can hear the caution in the wording. Possible, relic, biogenic, every word measured. The implication was still enormous. If those structures and minerals really recorded ancient microbial life, then the first persuasive evidence that life had existed beyond Earth was not dug from Martian soil by a rover. It was found on Antarctic ice by a meteorite search team. The reaction was immediate. The Smithsonian put the meteorite on display within days. Front pages ran with "Life on Mars" headlines. The White House paid attention because this was no longer a technical argument about mineral textures inside a meteorite. It was a public claim that humanity might already possess a fossil message from another planet. But the rock would not stay simple. The same features that made ALH 84001 famous also made it vulnerable. Carbonates can form without life. Magnetite can form without life. Organic compounds are not the same thing as biology. Even the tiny worm-like shapes were far smaller than known Earth bacteria. The most gripping image in the whole case was also the easiest to attack. The issue was never whether Mars had to be biologically dead. The issue was whether ancient life and ancient water-rock chemistry could leave nearly the same signature in stone. So the argument stayed open. Decades later, Researchers were still testing whether the evidence pointed to microbes or to abiotic reactions on early Mars. By 2022, new work argued that the organics in ALH 84001 could be explained by non-living interactions between water and rock. The most famous Martian fossil candidate on Earth did not simply collapse. It became harder to resolve and more unsettling. Geology can imitate life with unnerving precision. The Antarctic part was real. The ice had hidden the Martian stone, preserved it, carried it, and laid it bare. What it delivered was not an answer. As David McKay said when the argument began, we believe that these are, indeed, evidence of primitive life on early Mars. The mystery did not end there. One frozen rock was enough to start a controversy planetary science still has not buried. Number 2. The dinosaur in the ice. The predator that proves the white continent once had footsteps. In the austral summer of 1990 and 1991, geologist David Elliott was working high on Mount Kirkpatrick, above the Beardmore Glacier in the central Transantarctic Mountains. He looked down and saw large bones weathering out of black rock, not at sea level, not from some exposed coastal bluff. Roughly 4,100 meters up, about 400 miles from the South Pole, in a place where helicopters were the only practical way in, and the weather could shut the mountain down whenever it wanted. Antarctica is supposed to give you ice, wind, and silence. Elliott found a land predator. At first, that feels wrong. A dinosaur fits desert rock in Utah. It fits badlands in Alberta. But Antarctica jars the mind. The modern map makes it feel impossible. This is a continent buried under ice, with winter darkness and temperatures that can kill machinery. It is not where you expect a meat-eating dinosaur more than 20 feet long. But the bones were there, emerging from the early Jurassic Hansen Formation, one broken edge at a time. Paleontologist William R. Hammer and his team came in to excavate. What they pulled from the mountain was not a seal, not a giant bird, not some marine reptile washed into the wrong story. It was a partial skeleton of a large theropod, an animal built to walk on two legs, hunt on land, and leave tracks in mud. Later estimates put it at around 22 to 25 feet long. Its skull carried something even stranger, a crest running side to side across the top of the head, not front to back like a tidy textbook ornament, crosswise, as if someone had laid a blade or a comb across the animal's crown. In 1994, Hammer and William J. Hickerson gave it a name, Cryolophosaurus elliotti, the cold-crested lizard, Elliott's dinosaur. A scientific name, but also a verdict. This animal did not drift in from somewhere easier. It belonged to Antarctic rock. Now picture what the fossils imply. You are not standing in white glare. You are standing in a Jurassic landscape under a seasonal sky, about 190 million years ago. The ground is soft enough to hold prints. Trees stand nearby. Not flowering plants yet, but forests. Ferns, conifers, seed ferns. A living cover thick enough to support prey, scavengers, and a predator this size. Somewhere in that system, the carcass of Cryolophosaurus comes apart. Smaller theropod teeth end up associated with the bones. That hints that after it died, other meat-eaters worked over the body. Even here, in Antarctic stone, the evidence is not only anatomy, it is behavior, caught in fragments. This find does not depend on shadows, radar traces, or shapes seen from orbit. This is bone you can carry, describe, compare, and name. Bone forces the continent to admit what it used to be. Before this, Antarctica could still sit on dinosaur maps as a blank, white interruption. After Cryolophosaurus, that blank space filled in fast. The Hansen Formation began yielding a real ecosystem, plant-eating sauropodomorphs, pterosaurs overhead, scavengers at carcasses, forests on land. Not an isolated freak, a working Jurassic world. But the mountain kept one complication. Cryolophosaurus is famous enough to seem settled, and it is not. Early Jurassic theropod fossils are sparse worldwide, so its exact place on the dinosaur family tree has shifted from study to study. Was it close to the line that later produced the giant predatory dynasties? Or was it a stranger branch, an early experiment that left few descendants? The skull is clear. The skeleton is real. Its pedigree still moves. The puzzle was never only how a dinosaur could exist in Antarctica. The sharper question is how Antarctica could have been the kind of place where a predator like this made sense. You do not get a 22-foot theropod by accident. You get one because there is enough land, enough plant life, enough prey, and enough time for an ecosystem to stabilize around teeth. The same thing that made the question seem absurd also hid the answer. The ice did not create Cryolophosaurus. The ice covered the mountain that kept it. By the early Jurassic, Antarctica was not parked at the bottom of the world as an isolated freezer. It was part of Gondwana, joined to other southern landmasses on a warmer planet. Forested. Seasonal, yes, but habitable. Connected. A place where a large carnivore could walk across river plains and wooded ground instead of glacier crust. So when Hammer's team pulled that cold-crested skull from Mount Kirkpatrick, they were not finding the wrong animal in the wrong place. They were finding the right animal in a continent we no longer recognize. Above that lost landscape, at 4,100 meters on a mountain now locked in ice, the bones waited in the Hansen Formation until a geologist looked down and saw them breaking out into the wind. Number 1. The forest under the ice. A dinosaur already tells you Antarctica was once alive. Then, in February 2017, in the Amundsen Sea off West Antarctica, a drilling team pulled up something even harder to place on the modern map of the continent. Not a bone, not a shell, a piece of ground. Johan P. Klages and the Polar Stern Expedition PS-104 team were working near Pine Island and Thwaites Glacier, in one of the most ice-dominated corners of Earth. They drilled into the seafloor and recovered core PS-104_20-2. About 30 meters below the seafloor, inside a layer of dark sediment, scans showed a dense mesh that did not look like ordinary marine mud. It looked like roots. Frozen deck above, buried forest below. Roots change the case. Pollen can drift. Spores can wash in. Plant fragments can travel hundreds of miles and settle far from where they grew. A root network preserved in place is different. It is the difference between debris and a floor plan. In Core 10R, at roughly 29.34 to 29.43 meters below seafloor, the team was not looking at random plant remains mixed into ocean sediment. They were looking at something that behaved like ancient soil, still holding the structure of the land it came from. Laboratory work built the rest of the scene piece by piece. The sediment contained fossil pollen. It contained spores. It contained clay and silt consistent with a soil horizon, rather than loose material dumped there by currents. Deeper in the sample, the picture sharpened. This was not a cold ocean anomaly. It was a buried ecosystem. On April 1st and 2nd, 2020, the study appeared in Nature under the title Temperate Rainforests Near the South Pole During Peak Cretaceous Warmth. Its claim was simple. Beneath the edge of the Antarctic ice sheet lay evidence that this place had once been green. Not green in some vague, technical sense. Not a few hardy shrubs on a warmer shoreline. The layer was dated to the mid-Cretaceous, roughly 92 to 83 million years ago, in the Turonian to Santonian. At that time, the site sat at about 82 degrees south paleolatitude, around 900 kilometers from the South Pole, almost the bottom of the world. For months each year, the sun did not rise, yet the evidence points to a temperate lowland rainforest. That puts the find in a different category. A rainforest near the pole means more than warmer weather. It means a full ecosystem functioning under an extreme light regime, including long polar darkness. Trees and undergrowth were not just making it through a mild season. They were enduring months without sunlight, and returning each year in a climate stable enough to support soil, roots, and complex plant life. The climate modeling attached to the study suggested atmospheric carbon dioxide in the range of about 1,120 to 1,680 parts per million, along with a vegetated Antarctic land surface and no major Antarctic ice sheet. Not a continent locked under kilometers of ice, but a greenhouse Antarctica crossed by water, covered in forests, and shaped by a climate system almost unrecognizable beside our own. Officially, this is a sediment core from the Amundsen Sea sector of West Antarctica, a dark layer in PS 104_20-2. A paper by Klages, Ulrich Salzmann, Torsten Bickert, Klaus-Dieter Hillenbrand, Karsten Gohl, and colleagues. Measurements, scans, pollen counts, modeled CO2, stratigraphy, dry words, controlled words. What they describe is simpler and stranger. Roots and spores from a forest growing near one of the coldest places on Earth. That is, the larger secret Antarctica has been holding all along. Not a hidden bunker, not a pyramid, not a lost machine buried under the ice. The strongest thing preserved there is evidence. Evidence that this frozen continent once had forests, rivers, animals, and climate conditions radically unlike the white desert we know. The official record says ancient soil. It is a forest floor.